dipole. A dipole is created. So what does this mean? That there's a separation between the positive and negative charges. This illustrates the positive charge and the negative charge in the molecule. So essentially you just have to think of magnets, and this is what a dipole-dipole is. So this is an example of a dipole-dipole force between hydrochloric acid. So we have one molecule of chlorine, we have one molecule of hydrogen attached to each other. So chlorine pulls the hydrogen toward itself, creating a slightly positive and slightly negative charge. So this is illustrated between these symbols here, which indicate the electronegativities or the charge of the molecule. So this is just delta positive and delta negative. Once again, it just illustrates the charge. This occurs because chlorine has a high electronegativity. So when two hydrochloric acid molecules come together, as shown here, you're actually going to create a dipole between the two molecules, because the negative end of the chlorine is attracted to the positive end, the hydrogen. And so this creates a dipole-dipole force. So it's just like magnets. So like I stated earlier, the strongest type of dipole-dipole force is a hydrogen bond. This bond occurs when hydrogen is bonded to nitrogen, oxygen, or fluorine. So these molecules here. And the short form for this is NOF, NOF. So just to keep in your minds, hydrogen bonds happen between NOF molecules. Once again, this type of bond happens due to the separation of charges. So as you can see, there's a clear negative dipole with the oxygen and a clear positive pole with the hydrogen. And the water molecules will actually orient themselves. So the positive and negative ends attract each other. So you can see how the bond is formed between each of these individual molecules. So here's another example of a dipole-dipole force. This example is actually called a dipole-induced dipole force. And this kind of force only occurs between highly electronegative and polar molecules and molecules that have no charge. So for this example, we're using argon, which is a noble gas and therefore has no charge. And we're using hydrochloric acid, which we already know is polar. It has a very high electronegativity. So as argon begins to move closer to the hydrochloric acid molecule, its electrons are going to start to orient themselves towards the positive side of the hydrogen. So when this occurs, a dipoles are created. So the negative end is here, and the positive end is here, because the electrons orient themselves towards the positive hydrogen. And this kind of dipole-dipole force only happens between molecules that have a high electronegativity or are highly polar, because it takes a lot for the electrons in argon, for example, or any noble gas to be able to move towards something that is a high